Hello, everyone, and welcome to a new episode of our podcast, Step T with Elsayed. Today, I have a very interesting guest, and you're going to know that during our podcast. He had done a lot of stuff in the water purification technologies, and you will be amazed with his achievement at this early stage of his career. Our guest today is Dr. Nariman Yousefi. Dr. Nariman Yousefi is an assistant professor at Chemical Engineering Department at FIAS at TMU. Dr. Yousefi has pioneered the water purification technologies, and he did a breakthrough when he proposed a graphene-based sponge. This innovation can significantly enhance the water purification system for our future. It can remove a lot of contaminants, such as heavy metals, microplastic, and this is going to be very interesting to me to discuss with him today, how this innovative technology can remove the microplastics and the pharmaceuticals as well as the bacteria. How are you doing, Nariman, today?
Good. Thank you for having me here today. I'm very glad to be part of this interesting podcast.
Thank you so much for accepting the invitation and being guest on our podcast. By the way, what is your favorite drink?
Oh, I love tea, actually.
Oh, that's good.
I love tea. I love many different styles of tea, Chinese, Indian, Middle Eastern. So.
Oh, okay.
Yeah.
Did you try the step tea? We have a very special step tea
I'm looking
recipe.
forward to it today.
Okay, so let's try to see
For sure.
how that will taste with you. You're gonna like that as far as you are a fan of the tea. So now we would like to
Is it
have your
something
opinion.
you formulate yourself? Or?
Yes, but it doesn't have that much nanomaterial.
I hope so.
Yeah. So if we start with who's Nariman, can you tell us about your journey in your life?
Oh, well, as you mentioned right now, I am an assistant professor of chemical engineering in the Department of Chemical Engineering of Toronto Metropolitan University. I kind of feel like I was always wanted to be an academic, and I always appreciated to be a teacher. So kind of like what I'm doing right now is very much aligned with my aspirations. So right now, thank you for the introduction, but I can go a little bit more detail of what we do. Or
Before what we do, I just want to put you on a time machine.
Okay.
And go back. I don't want to go that much, maybe 20 years, 30 years when you were a child, and how did you do it during your high school, your university? How did you decide to go to chemical engineering?
Oh, well, that's a very good question, actually. So actually, my bachelor degree was in materials engineering, so I didn't go to chemical engineering. I switched to chemical engineering while I was doing my master's and PhD in grad school. I decided to do chemical engineering. But yeah, so thinking about it, I'm one of those really cliche, classic kind of cases. I was a studious student. I was always like doing my homeworks well, and I ended up in a good university and decided to do materials engineering. And a lot of people ask me, why materials engineering? It's a very specific topic. So my father is a materials engineer, and so the lingo of materials engineering, what was called metallurgical engineering, I heard a lot at home. And that was one of the inspirations for me. I was like, oh, I really like what he did. So I'm going to do that at school as well. And I'm very happy I did it. I was a basically successful undergrad.
So which university did you do your undergrad?
So I did it at Sharif University in Iran. So it's one of the good universities there. It's a top engineering school. Interestingly enough, when you said, let's look at back a few years ago, or when I started my undergrad, when I went to school and to the university, first term, I thought I will never make it to the end of it. It's so difficult. I cannot do it.
The big talk for
yeah. So I tell my students right now that is how I felt. Even when I struggle, in their PhD or undergrad or whatever, I tell them that I was really seriously thinking at the end of my first semester, this is not what I want to do. I don't think I have what it takes to finish it. But it ended up well at the end of the day.
Okay, so you finished your undergraduate degree in material engineering.
Yeah.
And then did you go to industry after that, or you decided direct to go to a graduate study?
No, so I decided to do graduate studies. So I came to Canada, went to McGill, Department of Chemical Engineering, and started working. That's where I basically get to work with environmental, materials, like using materials for environmental treatment. So the idea and the passion came from grad school, actually. So I did both my master's and also PhD at the Department of Chemical Engineering at McGill.
Cool. So have you thought when you were a child that you're going to be a professor?
Not really. But as I was going forward, I always realized that I like teaching. So that gave me a lot of joy. Even when I was in middle school, high school, I found a lot of joy, helping students who weren't doing really well. And I felt a lot of, reward in doing so. So when I started my undergrad and started doing some volunteer research in different research labs, I really knew that, okay, research is something that I want to do. Teaching is something I want to do. So that kind of set my, career path.
Okay. I see that you have some shifts in your career, but I understand that you get that inspiration about the material engineering from your father and what you have engaged with him. But what makes you shift from material engineering to environmental engineering? Is it the opportunity, or is it something that you decided to do?
So that's a very good question. So chemical engineering is more application focused. So in materials engineer, we really focus on materials. We don't really try to investigate specific applications. Yeah, there are applications for each materials, of course, but the most focus is on developing some new materials, discovering some new materials. But what I liked about chemical engineering was that it was very much application focused. And one of the application in chemical engineering, same as in civil engineering, is environmental science, environmental engineering, using engineering solutions basically to remediate the environment, to improve the environment, to monitor the environment. So that's why I shifted. I was like, I want to do something that is a little bit more environmental related. And usually, as we both know, it's either in the civil engineering department or chemical engineering department in different parts of the world, of course.
Yeah, so it's like you have a tool of, science, the material, and then use that as an application.
Exactly.
Yeah. During our journey, we do our graduate study, and during your graduate study, there are a lot of instructors and professors that has a positive impact in your career and inspire you. If you would like to name one or two professor or instructor who really inspired you during the graduate or undergraduate study.
Yeah, for sure. There were two professors who really helped me find my way. The first one was a professor in my undergrad. So his name is Reza Bagheri, Dr. Bagheri. And I volunteered in his lab as a summer student for a couple of years, actually. So I had a study buddy who's a professor now in the US. So he was like, oh, do you want to it seems interesting to join a lab and, work a little bit to get some hands-on experience. And I was like, yeah, sure. So we knocked on this professor's door. Okay. So emails were not that prevalent back then. So we knocked on his door and was there. I was like, oh, professor, we are two undergrad students, we're very much interested in polymers and we want to do some research in polymers. And we know that you have a research lab. And he was a very kind person. He was like, oh, but do you know anything? Have you taken any course? And we said, no, we didn't. You haven't taken any course yet. And I was like, yeah, so if you like, this is a book and, you can go read it anytime you want. Just knock on my door and have a chat. And every week we would do that. And now that I'm a professor, I'm realizing that how kind he was, because usually we don't have that much time. So for 2 years, I was volunteering in his lab as an undergrad student. And that really shaped my, career path. I knew that, okay, the research is something I really like to do. It's a new day every day. It's a new material every day. And then when I went to grad school, I really have to thank my PhD supervisor, Professor Natalie Tufengchi. So she was more a mentor for me. And I think that is very, very important to have a good mentor during your PhD, because they can help you. She asked me, what do you want to do? I said, I want to become a professor. And she was like, yeah, I see it in you that you can be. And we have to do a lot of things like for a few years, basically, to shape you in a way, to work on your CV and so on, to help you achieve that. And I really appreciate it because it was very much like solution focused, very much like, okay, what do you want to get to, focus on professional development and so on. So that is something that I try to do for my students as much as I can. I know that in academia, it's a mix usually. So sometimes some research labs really focus on the research skills mostly, and some research labs are not. But I think it's a good balance between the two. So your research skills and what you want to do afterwards, because that is the most important thing that we don't want to deal with when the student is graduating. It's too late already, like to decide, what you want to do now.
Yeah, so this is about your PhD supervisor. So we understand that the PhD supervisor role in our life is significantly important. But what stuff that you learned from your supervisor and you kept them with you while you are a faculty member now and you are supervising students? What the good thing that, my supervisor was doing this and I want to keep it and I'm trying to practice it with my current student?
Yeah, there were many different things. One of them was giving the freedom to do research. So giving the students who are willing and are interested in doing research to pursue their ideas. Because sometimes, and I appreciate it because my supervisor gave me this opportunity to make mistakes and learn from them. Not really big mistakes, but research mistakes to do and learn from them. And I like to provide that opportunity to my students as well, to have that freedom to work on their ideas, to see if they work or not, to give it a shot, basically. And I think that is very important. The lab environment is very important, to have a really collaborative lab where students work with each other and they're happy to come to the lab. I think that's one of the most important things for PhD students. I mean, these days we keep talking about, mental health of grad students, especially for a PhD program, which is very long, open-ended. And one of the things that can help them have a more safe place, more, cultivating place, is to have an amicable environment, to have lab members to help them, supervisors that help them, staff that help them, and so on. So I've been striving, and I learned it from my supervisor because our lab was very, very amicable, collaborative, and so on.
So if we're giving you the opportunity now to say something to your supervisor, what do you want to tell her?
I would say, thank you very much, Ali. You gave me this opportunity. I'd like to thank you. And a lot of things that you said that I didn't realize back then, now I understand.
Yeah, this is the point. We realize
when you go back, okay.
And this brings the thing that is during our, graduate study, we have some up and down. Some days it's an amazing day for us, and some days are really not the good days. Mm-hmm. If you bring your maybe memory back to those days, and if you pick one or two good memories that during your graduate study, what would you remember? What comes to your mind?
Well, yeah, many things. Well, usually we become very happy when
that means you have a happy life.
Relatively good. Of course, for any grad student, when you publish papers, get awards, this sort of things, graduate, these are like happy moments. But for me, the happiest of them was when we finished work and the grad student would go for, a drink, for a coffee, for some tea. And that was a really good cap on a day. And that gave me a lot of comfort at the end of the day when we went to, especially in cold winters of Montreal, getting, a hot coffee or the hot tea, basically is very nice at the end of the day. Yeah.
So are you trying to practice that with your graduate students those days, that to take them for a coffee or for an ice cream or?
I have to say I'd like to do more. Yeah,
okay.
I have done that before, but I'd like to do more. Unfortunately, COVID caused a lot of disruption in universities. Most of the cohort of the students that I have right now, we hired them during COVID. At the beginning, it was now when we look back at it, it's really strange because for 2 years, you didn't really see your grad student in person. It was all online. But yeah, this is something I'm really looking forward to this summer. We were just in May now. The fact that we can do a lot of fun stuff. Most of my grad students are about to graduate. So they're towards the end of their program, so they're a little bit more relaxed and more time. Yeah.
Maybe you think this year to do a barbecue with them.
Yeah, sure. Yeah, definitely we're going to do that. To a park.
So this is about the good memories during our grad, but sometimes also during our grad studies we have some like a tough time or a hard time. Do you remember something that happened during your grad study that was really tough, and what did you do to overcome that?
So there was this, this is again quite cliched. The rejections, paper rejection, board rejection is usually like very tough. But what I found the toughest was that my work was mostly experiments, and a lot of the time the experiments didn't work, and I had to figure out a new way to do things. So that was the most challenging part. And I always tell my students that PhD is a game of perseverance. You need that skill more than anything else because it's open-ended. It's usually multiple years. It can take 3 to 6 years, for example, in engineering, depending on what kind of project you have.
6 years. You start to scare the...
Yeah, there's limits. Yeah, 4.
Typically it's 4, maybe exactly, a little bit.
Exactly. So basically, keeping that spirit and persevere through all the difficulties is something that students need to like cultivate. At the beginning, it was very difficult for me to gain that. But one of my mentors, actually, another professor, told me it is a game of perseverance, and this is his words. And it was like, you have to like make sure that even if you fail, you come to lab another day, take some break, come to lab another day, try to use another technique, talk to people, so on and so forth. But those moments, especially when you think you have a really big idea and you go to the lab and you want to do something and you do it and then it fails, it's really heartbreaking.
Yes. So focusing on the current life as a faculty member, what are the research areas that Dr. Yousefi is working on?
Yeah, so my research is at the intersection of nanomaterials, so nanotechnology, and environmental engineering, in particular water treatment. So we are trying to discover new materials that are very efficient in removing multiple classes of environmental pollutants. We mostly in my lab, we work on 2D nanomaterials. For example, as you mentioned, graphene-based materials, graphene oxide. These days we're working with boron nitride, graphite carbon nitride. So these are all 2D structures at nano level that have very high specific surface area. They have very good, reactivity that can interact with different kinds of pollutants. Some of them can be like degraded, some of them can be removed, and so on. So that is the general theme of my lab.
So for a new student who is reading about those topics, can we define what is the nanomaterial? A basic definition of a nanomaterial.
How do we define nano? Yeah, yes, basically, so of course, these are a little bit of a gray area, but the most accepted or most prevalent description, nanomaterials are materials that have one dimension that is smaller than 100 nanometer. So they're very small. They're like much, much smaller than, for example, a strand of hair. And they have a whole host of new properties because at that length scale, you have certain kinds of material properties that become more prominent. For example, like quantum effects, for example, the surface area that is very high, reactivity that's very high, and so on. So they're a little bit different from traditional materials, and the properties that they impart to your structure or device is going to be very different from other kinds of like bigger materials as well.
Okay. So I would say that you mentioned that the nanomaterial has a lot of applications. So if you can elaborate about what is the role or the roles of the nanomaterials in solving the global water challenges nowadays?
Yeah, so that's a very good question. They're helping in multiple ways. One is to improve the current technologies. For example, let's say membrane technology is being used for desalination, for removal of dissolved contaminants, and so on. But we have the problem of fouling on membranes, biofouling. And nanomaterials are helping a lot to tackle that. For example, by making the surfaces of membranes antimicrobial or very hydrophobic. So pathogens cannot attach to. In another, for example, perspective, they are helping to build new materials, new functionalities, new devices. For example, what we are doing in our lab is not to improve something, but we're trying to make, for example, as you mentioned, sponges that are entirely made of nanomaterials, or they're enabled by nanomaterials to remove different kinds of contaminants at a very high capacity and at very high reusability. So that, for example, a filter that you bought to filter your water can last much longer, or they can remove specific contaminants that conventional filters cannot remove.
Okay. When we talk about the nanomaterials in general, we have always some people support that the nano materials and nano application because of its positive impact, but there is no technology or something without challenges.
Of course.
So what are the main challenges of applying the nanomaterials?
Yeah, the major challenge is price, because in water treatment, we are dealing with large volumes. You want to treat large volumes. So the price of each unit that you make, a filter that you make, is going to dictate basically a lot whether it's palatable by the industry or not. And that has been the biggest challenge. The challenge is slowly becoming overcome because the price of nanomaterials are dropping. It's being used now. A lot of nanomaterials, such as graphene, for example, now are being used in other fields. They're being used in electronics, in batteries, even in the structural, for example, in concrete. I've seen graphene being used at an industrial scale. So that is driving the price down. So we are hoping that in the water world, in the water industry, the price will go down as much as, for example, let's say activated carbon, or an ion exchange resin or something like that, which is very conventional to be used. So that will come in a few years, but up to now, that has been the most important challenge. The second one is that whenever you propose something new for the new system to adapt to it, there's always some time. And we have all these, for example, Greek centralized water treatment plants. They have been using established methodologies, established processes, and replacing them is a little bit difficult sometimes. So that needs some time to be able to basically use nanomaterials.
But what about people who are saying that there is a harmful impact of the nanomaterial to our environment if we are using it significantly?
Exactly. So that is always a challenge. Like the release of nanomaterials can be challenging. So there are some mitigating factors there as well. For example, using nanomaterials that are less reactive from materials that are not as problematic. For example, that's why we are mostly working with inert materials such as carbon. Secondly is that to design them in a way that they don't get released a lot in the water. Yeah. So locking them in structures, in 3D structure, locking them in with polymers and so on. But yeah, for sure, any kind of material that you use for water treatment, you should make sure that it doesn't get released to the water. You don't want to create more problems by solving one problem, creating more problems somewhere else.
Some of those materials, sometimes it's toxic when it's at nano level.
Exactly. So yeah, any kind of design based on nanomaterials requires a lot of studies to make sure that you don't have release. If you have release, is it safe, to what level, and so on. So always, it's always a multi-pronged approach where you have design of a system, then you have to make sure that it is dependable, then you have to make sure that it's safe, in what conditions it is safe, like any kind of engineering problem that we try to solve.
So those nanomaterials, as you mentioned, for example, the graphene-based nanomaterial that can remove the microplastic. So if you want to tell people, what are the major challenges of the microplastic nowadays?
Yeah, so microplastics is we're getting more and more knowledge about microplastics and nanoplastics because we have smaller particles as well. And unfortunately, in any waterway, in Arctic region, any place, like places that humans have not lived, you're seeing these plastic particles. Now, are they problematic? Are they not? There's a lot of research being done. What we know well is that they can be transported long distances, for example, in water, even through air, they can be transported long distances. They are their surface is usually reactive, so they can act as a vector for contaminants that were at low concentration, but it can act as a vector, make them more concentrated and transport them from location to location. So this is a challenge given the amount of plastics that you're producing every year. Now, a lot of research has been done on identifying these plastics in the environment. A lot of research is now being done on how to remove them from the environment. So that is one of the areas that we're working with, not only with graphene, with different kinds of techniques that we're trying to figure out what is the best way to remove them and efficient and, not too costly to remove them from the environment. So the sponges that you mentioned, recently we have realized that it can remove microplastics and nanoplastics as well to a good level. Still, there's work to be done in that area. But yeah, that's going to be one of the big things we're going to see in water treatment, community, is to how to mitigate the microplastic problem, how to mitigate the nanoplastic problem. Because as you know, plastics are in the environment for a very long time. They remain there. And even if we stop all the plastic production today, which will not happen, of course, you've had like 50 years worth of plastics that have not been properly disposed of to a great deal. They're either in the landfills or they're in our waterways, they're in the oceans. So they're going to stay there, they're going to degrade, and they're going to release plastic particles, including microplastics and nanoplastics. So we have to figure out a way to make sure these particles can be removed from our water.
Yeah, so I can imagine that the sponge material can remove the micro or nanoplastic in water because it doesn't have much solids. But when there is some solids in the stream mainly, I believe this sponge or something like that cannot work, or it's still working.
But you mean like larger, like bulk plastics? Well, bulk plastics, they mitigate.
No, nanoplastic and microplastics,
yes,
small particles, and it get contaminated with particles,
yes.
like solids.
Yeah.
So, for example, does it apply the same concept with a wastewater stream, for example, or it's only for water?
No, in wastewater stream as well. I think the problem is more prominent there.
Yes, that's why, yeah.
Especially industrial wastewater, agricultural wastewater. You see a lot of microplastics and other kinds of plastics in your stream, and finding a solution, maybe like filtration is not the best solution there. Maybe there are better solutions based on coagulation or other kind of techniques. Even like plastic degrading bacteria, that is the main, that's an area of research these days. So of course, for sure, in wastewater, that's going to be a more prominent problem than drinking water.
Yeah. One of the major challenges nowadays I heard about the microplastic or nanoplastic research is how to quantify them. So there is any light at the end of the tunnel for having a reliable quantification method for microplastic or nanoplastic?
Yes, so that's a very good question. Actually, that's one of the biggest challenges. It's not like any kind of dissolved contaminants that you can go take a sample, calculate or measure like how much, for example, PBDE you have, or how much, for example, lead you have in water. With microplastics, because they're particulate, they have various kinds of shapes. They have a very wide range of sizes. You can have a few nanometers up to like few millimeters. So many techniques don't work in that wider range. There is some light at the end of the tunnel. Actually, my research lab, we're working at quantifying microplastics right now. Artificial intelligence, machine learning is helping a lot. We are currently with our collaborators in different departments. We are trying to build models that can use big data. They can use like artificial intelligence and machine learning techniques to basically identify plastics versus other kinds of particles, because you have a lot of kinds of particles in the environment. So that is going to be very helpful. Robotics is going to be very helpful. That's another project that we're doing with the collaborators, where with the help of underwater robots, we're trying to identify plastics in the environment. It's very, very challenging work, because you have to basically develop sensors from scratch to be able to detect these. But I think, we're not there yet, but I think the research community in the next decade will most likely come up with new techniques, new methods to identify these plastics, standard ones that hopefully we can run, in the standard water labs or maybe at home even to identify these particles.
Yeah, I know that at Waterloo they are doing similar thing when they developed something called the plastic net, where they are using this application of artificial intelligence, and I think the microscopic images and do a bunch of huge data and feed it to the model so they can come up with something like that. So I think, so there is a light at the end of the
tunnel. We were hoping that AI saves the day, basically.
Okay, AI, there are a lot of opinion about the AI and machine learning. A lot of people see the positive impact on the future, and some people hesitant a little bit of replacing some jobs or reducing the opportunity for jobs a little bit. But maybe this brings okay, I can see that they're enjoying when you are talking about your research. And this is typically what our graduate students feel, that our life is it's a relaxing life. Those professors are laughing. So they feel that this is not tough time. So as a professor, there is always a favorite part to your heart that you want to do, because for those who don't know, a professor has multiple hats. You are a teacher, you are an instructor, so you are teaching for undergrad and graduate. You are a mentor for your graduate team, and you are a researcher doing research, applying for a grant. And besides that, you are doing also an administration work as well, committees, blah, 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 and some volunteers. So there are a lot of activities for you as a professor. So what is the favorite part of being a professor to you?
That's firstly, you said something very important. In the parentheses, I want to say, as grad students, I never saw what goes behind the scenes to run a research program or to be a professor. I had no idea what it goes. We just saw, okay, this is research paper. Professor reads the paper, gets some grants.
And if you don't respond to the email, why is not responding?
Why is not responding? Exactly. Now I realize, oh my God, there's so many other things that you need to do to make sure that your research program is running, and also your teaching and everything, committee work, everything is running smoothly. So many small moving parts. So that was a very surprising part for me when I started doing my position here. But a favorite part, I think the most favorite part for me is, and I'm finding very rewarding, is when you see that you have had a positive impact on students. And I want to, for example, give an example of one student, an international student, came in an MN program, so course-based master's, and was taking my environmental nanotechnology course. And in that course, we have a lot of presentations. So she came to me and wanted to know if it's a proper course for her or not. And told me, professor, in my home country, in my university, we didn't really present anything. We didn't do any presentation. And I'm not sure if this is a good course for me or not because of this. And I was like, okay, I asked her, I wanted to know what she wanted to do. And was like, what do you want to do afterwards? And she was, I want to work in R&D. I want to have an engineering job, but a little bit more research focused. I was like, that one of the skills that they're looking for, the companies that you'll target, is good presentation skills, with good scientific communication, technical communication. So it's up to you, but I'm telling you, if you really want, take this as a challenge for yourself in this course. Try to do this and come to me at the end of the course. In case you think that you want to drop it, I'll let you drop the course at that point, okay? And then she took the course, got a very good grade. And I saw her a couple of days ago, and I was like, oh, what are you doing on campus? Because I thought she has graduated. And she told me, professor, I'm a PhD student now.
Oh.
And I really have to thank you, because, that conversation we had made me very much interested in doing research, in really trying to think out of the box, really push my boundaries. And it was a very, very pleasant day for me, because I was like, I could influence some person, and I could in a positive way, and I could hopefully change their life for a better one. And that is really, really rewarding. And every time, from time to time, you see some students come and say, oh, by the way, professor, that book that you mentioned on, let's say, plastic pollution, I read it and it was very interesting. And that was not part of the course. I just said, and realized that, really, some students actually get impacted by you. And I find that really, really rewarding.
Yeah, I see. I think it's for most of the professor when you see your effort is get reflected in one of your students. This is something really paying off your hard work. But I just remember something when you mentioned to the presentations, and you said that the graduate course that you designed based on multiple presentations. I did one, I would say it's not like an experiment, but one time I said, okay, for a graduate course, each student will present 3 times. And 50% of the grade will be based on the improvement in your presentation from one to another. It's not the quality of your presentation,
but the journey.
The journey. Did you take the notes or the comments from the class and you improved your presentation right after? And I was impressed, honestly, with some of the students who are coming from a very shy area that very, they couldn't really present well because, we all back home, we didn't get practice to those things. And it was really something amazing at the end of so I can see. But this is the good, let's say this is the good part, but always there is a tough part.
Yeah, tough part, exactly.
I wouldn't say that. Let's put it the least favorite part of being a professor.
Yes. For me, it's grading.
Marking.
Yes, marking and grading. Although we have, of course, we do it, of course, but it becomes a little bit tedious, especially at the end of the term where you have like 2 courses to teach and you have a lot of papers to grade and a deadline to meet. I think that part, for me at least, is the least favorite that I have to do. But of course, the student needs their grades, so we have to do anything else.
Yeah, I remember when I was teaching that large class, I used to have maybe 3 days, full days, just sitting grading this class, 108 students. That was like, that's time consuming, but it's again, yeah. So going back from your professional practice to your personal practice, what is your hobbies? Outside research.
Outside research, I really enjoy cooking.
Okay.
I enjoy cooking many different cuisines, and that's how I challenge myself sometimes, going like trying to find a cuisine that I have never tried and basically trying to make it at home, new ingredients and this sort of things. Basically, our job as experimentalists is always, like cooking. You do it in the lab, you make new materials at the home, you can make food. But yeah, I really enjoy it. There are like books that I read about it. I even travel to areas of the world that I want to learn more about their cuisine, try their, different cuisine and
that's
try to recreate them. But living in Toronto has one advantage is that you have access to ingredients that barely you can find in any other city because of our multicultural, diverse community here. You basically can find ingredients that are very difficult to find even back in the particular country. Like even, for example, where I come from, Iran, some ingredients that I find in the supermarkets in Canada is difficult to find there, to be honest. So that is a really good opportunity, basically, to try different cuisines with natural ingredients and also original ingredients. And then you have all these restaurants that you can go and try you're making versus what is supposed to taste like.
But that maybe this is your wife is so happy with that hobbies that you are
my
cooking
spouse,
at home.
Yeah, it's very happy. Yeah.
How often did you cook at home?
Weekends mostly.
Oh, okay.
Yeah, weekends I do, and during the week.
So if you have a secret recipe or something that you want to share with the audience, that is something that is...
If I shared it, wouldn't be secret.
Or let's say one great...
There was a soup noodle that I had, spicy soup noodle that I had in Hong Kong, which is a recreation of something made from the Sichuan province in China. In mainland China. So that particular one, I could not find any recipe, and I worked a lot on recreating it. I spent like many weeks trying to recreate, not continuously, but I've eventually found one secret ingredient in it, but I can share it with your audience if they're interested.
Okay. maybe we can have a different episode about
professors cooking
and cooking. But cooking a lot makes a lot of disaster sometimes.
Yes.
Have you made something recently like? So you cook the thing and then just throw it, because I do that all the time when I.
Oh yes, I have. You just pick up your phone. Yeah, you forget what's on the stove, and it just you hear the fire alarm. You realize, oh my God, I did something wrong.
Okay, so if we have a time machine and we go to any time in the past, any era, and want to select a historical figure or historical person that you want to meet and have maybe a meal with her or him and have a chat, who would you select?
That's a very good question. I think two of the figures that I really admired as an engineer, one is Thomas Edison, and the other one is Nikola Tesla. So these two, as you know, were rivals. They were really, really, they had a major rivalry on, their innovations back at the beginning of the 20th century. I would like to have them on the same table, not just for the sake of conversation, but because of the drama that boiled there between two rivals. But yeah, both of them I really admire. I admire how Thomas Edison basically was an inventor, but at the same time, a very, very successful businessman. He could take the ideas from his lab into to shelf basically, and how Tesla was so scientific minded and innovative, but he lacked that business perspective. But he was very, very good at making new things. So I think both of them, for me as an engineer, I like to be a combination of the both. So be innovative at the same time. Be industrious as well. So this is something that we don't do. I mean, I don't know much. Yeah, and I'd like to do more, like to make things that you will see when you go to purchase something, like more tangible stuff.
Okay. So you are a professor now, assistant professor, and you have your research team. And being a professor, we received tons of emails and a lot of contacts from a student they are looking for an opportunity for a graduate study. What the criteria that you are looking for selecting a student in your team?
Yeah, that's a very good question, actually. So I personally mostly look for potential. So I look at their backgrounds, of course, having papers, having good grades, having good recommendation always is good. So, but what I really look for in students is whether they have the potential to grow. So the growth, as you mentioned in your course where you have the journey, I think growth is the most important thing. Whether we can take one person and take that person from point A to point B, and B is bigger than A, that is very, very important. And I pay attention to that. The other thing that I pay attention to...
How to measure that, the potential?
It's very difficult, actually, mostly in interviews. So I do usually multiple rounds of interview, and I try to see what the student's aspiration is, what they want to do, what career path they want to take. I want to see if the students actually think about these when they're looking for grad studies. The second thing is I really try to see if they can fit well with my lab environment, because like I said, having an amicable environment, professional environment where everybody collaborates and helps each other is super, super important for the mental health of the students. I try my best, and sometimes you can't really do that, but I try my best to make sure that the student is a very good fit for the lab environment that we have. So these things I pay a lot of attention to. Like I said, in similar background, for example, any background in water treatment, in materials, of course they help. Publications help a lot, especially if you're looking for PhD students, they help a lot. But I don't focus too much on them, because for various reasons, you might not be able to publish a lot. For example, maybe you're from a lab which like a professor is at the end of the career, might not be super active, or for any reason they might not be active in publishing. So it doesn't mean that the student as graduate from that lab cannot land a PhD position.
So you still give opportunity to some potential students who have potential
Yes.
and have the mentality of teamwork, but doesn't have a record of application, but they can show that during the inter.
Exactly. Yeah, as you know, these days it's usually recommended that we have a holistic approach and not to have, like GPA of this amount, and so I'll try to have that as I strive. I mean, it's very difficult actually to have a more holistic approach to see as a whole, as a whole person, as a whole student, how the students will perform in this grad program. But
yeah, so students nowadays are communicating with us as a professor through the emails, and you receive multiple emails every day from both mainly international students who looking for an opportunity. What catched you in the email to look at the email and say, oh, that's this, I can have an interview? Because definitely you're not going to be able to look at all the students. What is important that you are looking in the email? If you want to give an advice to somebody who wants to reach Dr. Yousefi through an email.
Yeah, that's an area where there are a lot of opinion about, like whether to be brief or not to be brief. I usually prefer to be brief, even if it's very long. I usually do not read the entire email. I look at the CV.
Okay.
So my recommendation is that be very careful about your CV. Make sure you proofread it. There's no typo in it, and have the information that is required there. For example, what you studied, like your record of studies, your GPAs, the title of your thesis, if you did a thesis, so in your CV, so in one look we can see all of them. Because there are some students who send like multiple files. Okay, this is my transcript, this is my recommendation letter, just in that email. And professors usually don't have time to go through every single one. And if you can summarize all of them in a CV, which is an art actually, how to summarize my entire academic life in 1 or 2 pages. And just the most important things that a professor are looking for. So professors are looking for what degrees you have, what was your GPA, when you did them, where you did them, if there was a research work, for example, the title of your thesis, name of your supervisor there. So all of these can be there. The record of publication. It's usually good if the students have Google Scholar, or I don't know, ResearchGate or whatever service that they use to put a link, because nobody prints things anymore. We just see them on the screen, and we can click on it and then download your paper if you're interested, or read the abstract if you're interested. You don't need to attach all those things. But if it's not there, it's very difficult to retrieve. It takes a lot of time.
Yeah, I would add to that a couple of things for those students. Avoid the generic email, because sometimes you see, the email is not meant to me, but it's just a very generic email. So those emails typically we don't go through. The other thing, we value the volunteer work. So if you did any volunteer or any community engagement work during anytime you're this is something appreciated and we are looking for. So you selected a student and she or he had been admitted and coming to your office for the first time ever, you're having the first meeting. What advice would you give them in your first meeting?
Well, that's very good, actually. The first thing that you have with a student, I would tell them to work on their transferable skills from day one. So that could be their communication skills, presentation skills, anything from day one, because these are things that you cannot do at the end. I will tell them about the perseverance. That is very important to know that this can be a bumpy road, and for some people it's easier, for some people it's more difficult. It depends also it really depends on their personal particular circumstances as well, right? I tell them about the importance of literature, because that's, again, you have some students who are really good in that. They do all the experiments, but they're not on top of the literature, and they don't know about the precedent, like what has happened before in the academic environment. So they're basically, some of them are reinventing the wheel. So they're trying to get answers for questions that are already answered, and that is a waste of their time. And so I really recommend them to go back and then do the literature review throughout the time. Because what happens is that at the beginning, students do it because they want to write a proposal, they want to do a directed studies and so on. So they're very good with the literature, but that gets old and stale after 2 years. And then when they're writing their
The thesis.
or the paper, for example,
yeah.
so, professor, I found this paper that answered this question. And it was like, okay. So you really need to do it from time to time. Of course, you cannot do it every day. I tell them to put those alerts, that you can put in many of these databases where with the keywords that you're interested in, if anything gets published, you get an alert by email and you go read them and hopefully present them, for example, in a group meeting, and you get lessons from that.
So after finishing our PhD, or the students finish their PhD, they have mainly one of the two careers, either to go to industry or to go to academia. So, and some of them, they have their own, which is not much of the students, like they're entrepreneurs, so they can have their own business later on. But if two students came and joined your group at the beginning, and one of them said, Dr. Yousefi, I am to it, I want to be a professor. This is what I see myself, I want to be a professor. What would you advise her or him to do during his PhD?
Yeah, so if they come to me and say that, I usually ask this at the beginning. So in that meeting,
so that's good.
Yeah, in that meeting that you said at the beginning,
Yes.
I usually ask them, and from time to time, because this is a dynamic thing. Some students say, I want to be in academia. And I say, no, I changed my mind. Actually, I want to do more like an R&D job, or I want to be in consulting and so on. So I usually ask them what you want to do, what's your end goal. If they say that we want to stay in academia, there are a set of things that I tell them to do. For example, I ask them to focus a lot on publications, because that's the most important thing from the first year. Because we cannot wait if the student is looking for academic positions, be it a postdoc or a faculty job or anything, they cannot wait until the last year of their PhD to publish. They need to publish so that their work can be seen by their peers, so they can go present it. So that would be my recommendation. I will make sure that they are involved in collaborative work that we do. I will make sure that I give them the opportunity to collaborate more, because that will give them opportunities to do research more and to publish more. I will send them more to conferences, academic conferences, because that's where they can be seen and the work can be seen and they can get feedback. Because sometimes you go to these conferences, you get positive or negative feedback that can impact your experiment design in your thesis design, basically, and you're catching it early on. And awards, basically, opportunity to present and get awards, hopefully, if they present well. So these are things that I really recommend them. If they, on the other hand, if they say that, no, we want to do...
Let's still on the academic part.
Okay.
So yes, so number one is publication, going to academic conferences and making the collaborative work. What about teaching?
That's a good point. Yeah, that's what I wanted to mention as well. So teaching, if the institute permits them to teach. For example, at TMU, usually PhD students cannot teach. So what I usually give them as an opportunity is to, after they pass their candidacy exam, especially, to basically guest lecture.
Yes.
To come to one of my courses, like a grad course or up a year undergrad course, and do a guest lecture. So that was an opportunity that I got when I was in grad school. So in multiple courses of my supervisor and also other professors in our department, now also outside of the department, I got the opportunity to go get a topic and teach it, or just present my research to a student as an application of that particular course. So I really recommend those students to pursue it. Doing tutorials is a very good way of doing it, because you need to be in front of a class to not feel scared and be more natural in front of students, and that comes with practice. Some people have it from the beginning, but for some people who might be challenged a bit, doing tutorials, so if they can volunteer, if you're TTAing, instead of marking, they go to that prof and say, hey, can I do tutorials instead? Because I want to have contact. Can I do a lab? Can I do a demo in a lab? So these opportunities will help them naturally find themselves in the classroom environment.
What about the other side?
The other side, well, with the academic side, I have a lot of experience because I've gone through it. With the other side, but what I recommend to them is learn networking from early on. So that is, again, another skill, a skill of networking, attending all these events that might be a little bit boring at the beginning, to just go there, talk to people, they might be shy and so on. So to break that ice, they need to start maybe from the middle of their work to go and, present themselves in networking events. These days, most universities have like career centers. There are universities are putting a lot of effort in professional development of students when they prepare them for after graduation. So go to those centers to talk to them, to get advice, the workshops, for example, on how to, for example, like improve your LinkedIn or how to improve your CV or these sort of things. They need to start early on and work on it. Towards the end, it's too late usually. And another thing that I recommend them is that internships, especially towards the end of their graduate degree, are very good for landing jobs. So when they're closer to submitting their thesis, if they're a PhD student, for example, if they can have an opportunity to go intern somewhere and then make some connections there, that would be very good for them.
And I think this is something we really miss nowadays, because if you remember a few years back, there was a grant called NSERC Engage. This is where you can have, I know it was meant for the professor to get a collaboration with new industries. But I remember during those days we were practicing to engage the postdoc or the end of their career PhDs, so get engaged with industry, talk to them, so to get some connection. I believe so. We need to talk to NSERC to bring this back.
Exactly.
Can help a little bit. Yeah. But does that career for the students affect your selection for their topic? So if someone will say, I want to go to academia or industry, does it affect which research topic would you assign them or advise them to work on it?
In the direction of their work, yes. So I don't, for example, change the topic, but in a direction, I make them more applied if they want to do, for example, industries. I had one student came to me and said that my ideal job is to work, for example, in an environmental monitoring lab or in an R&D lab. I was like, okay, if you want to do that, make sure that you learn a whole host of analytical techniques and try to like incorporate it in your thesis. Work with different kinds of, in my field, for example, different kinds of contaminants. So broaden your work to include those. It might not be cutting edge science, but it is a skill that you will develop that will be very useful for you. If it's a student who says that I want to do more cutting edge research, then I would say that, use these bunch of techniques that have no industrial relevance now, it might have in future in 5 years or 10 years, but use that for your work because those are newer, those can be seen more, those can be published more. So we try to like tweak their project in a way to fit their career goals.
Okay. Students came to the end of their PhD study and they are looking for a job and they're struggling as always. And they came to you, Dr. Yousefi, what to do to get a job? I'm trying for a few months. I'm putting some effort. What hints would you give to a PhD student who is looking for a job?
I would tell them that somebody told me this before, that finding a job is a job by itself.
It's a full-time job.
Yes, it's a full-time job. So you really have to maximize statistically your opportunities. Send as many CVs, attend as many networking events, and so on and so on. If it's for postdocs, send as many emails to a broad range of professors, apply for different kinds of scholarships because that usually makes you more attractive for your host lab. So that is what I will tell them, that it is normal. It's okay. It's not your fault. And searching for jobs, especially industrial jobs, consulting jobs, this sort of things really depends on the economic cycle. So if you're in a downturn like what we are now, there are going to be more limitations there. And sometimes we have booms and there's so many jobs, you don't even need to think. You basically, that will determine the graduation of the student. They go, well, professor, I have a job. I want to like graduate, please. Let's do something. So it really depends on that. So that is really not in our hands. It's really just luck that where you end up. But I would tell them that the perseverance that you learned in your PhD, now this is what you have to have.
You have to have that. Nariman, if you are not a professor, what would you be?
Yeah, that's a good question, actually. Not a professor. when I was when I was thinking about what field to choose when I was undergrad, there were a bunch of them that I really like to think as an alternative. One of them was to become an architect. Now I know that I wouldn't be a good architect.
You realize that?
Yes. Yeah. So I'm happy that I didn't go that path. Yeah, I basically knowing myself now, I know that okay, this is not something that I would succeed at. But I really enjoy law, so I think I would try to pursue something related to law. Yeah, that's very different, but
so
it's a very different field. But I like different and not different because we professors like to write, right?
Yes.
Yeah, to read and write and
not all the time, but
not all the time. Yeah, but
we have to.
We end up doing it. Yeah, mostly.
Yeah. Okay. So we came to the last question, and this is your camera. If you look at your camera and you want to give an advice to the young water professional, what would you tell them?
Well, it's going to sound a little bit cliche, but really think out of the box. Try to push the boundaries. Yeah, that's the advice I can tell. Perseverance is very important to get to your goals.
Thank you so much, Nariman. It was really a pleasure talking with you.
Same here.
And I enjoyed that time. Thank you so much. Really a pleasure. Thank you so much, everyone. And this is the end of our episode. And looking forward to see you in another episode. Please don't forget to follow us in every single episode. See you later.